Hi, welcome back to my channel. I made the connection with the Google Cloud Services decision trees, services comparisons, and alternative service options. You can use this connection to pick up the right Google Cloud Services or prepare for your Google Cloud certifications exams. You can take a look at each service's details in my YouTube channel. Let's walk through the first one, storage and database decision tree. The decision tree starts with the questions, is your data structured? If it is not, choose cloud storage. If your data is structured, does your workload focus on analytics? If it does, you will want to choose Cloud Bigtable or Bigquery, depending on your latency and update needs. Otherwise, check whether your data is relational. If it is not relational, choose Cloud File Store. If it is relational, you will want to choose Cloud SQL or Cloud Spanner, depending on horizontal scalability. You can go to the following two GCP web pages to review GCP storage products and GCP databases options. Let's quickly go through them. The first one is the storage products. You can see the use cases for each product. For example, cloud storage for object, blob storage, archive storage, the persistent disk and local SSD for block storage. By the way, my blog lists the comparison among the storage options, and I will make a video to talk more details among persistent disk, HDD, and SSD. You can see the file store for file storage. Mobile apps use cloud storage for Firebase. And you will see the transfer service to transfer data from on-prem to cloud or cloud-to-cloud transfer. By the way, I didn't see any collaboration questions in my exam, but you might want to know the high-level concept of the collaboration products just in case. The second page is on the databases options. The GCP database servers for the relational and non-relational databases such as Cloud SQL, Cloud Spanner for relational databases, Cloud Bigtable, Cloud File Store for NoSQL databases. I like this comparison table on what are you building. For example, if you need global data distribution and scale insurance for the relational databases, then you should choose Cloud Spanner. It also lists the other features on those services such as replica consistency, the multi-primary joins and complex queries, real-time sync. So this is to give you an idea how to choose the right service for your database options. You can also go to the GCP documentations to review the details on each GCP service. At the last, I summarized GCP storage and database decision tree with the keywords and the use cases for you to easily remember for the exam. The options divide into object, relational, non-relational, and data warehouse. For example, the cloud storage is for unstructured data, archive, temporary storage. It is the lowest cost storage option for up to exabytes. The use cases include images, media serving, data lakes, or backups. A cloud Bigquery data warehouse service is different than the other OLTP service in this table. It is for OLAP. Well, you got the points. Pause this video if you need more time to review the keywords of each service. Let's walk through the second one, computer options decision tree. The decision tree starts with the question, are you developing the mobile HTML app? If so, choose a Firebase. Otherwise, if you are developing the event-driven app, then choosing Cloud Functions. If the application has some specific requirements such as a specific OS or kernel or GCP access, or it requires you to lift shift from on-premise to public hybrid or multi-cloud deployments, or the monolithic workloads, use of protocols beside HTTPS, then you should use the Google Compute Engine, GCE. If you plan to use Kubernetes as a orchestrator or the apps needs containerization, then choose Kubernetes Engine, GKE. Otherwise, you use GAE, Google App Engine the platform as a service option to build a highly scalable web and mobile end applications on fully managed platform. Again, I summarized the computer options decision tree with the keywords in the use cases for you to easily remember for the exam, like I did for the other decision trees. You can find the details of the comparison among GCP compute and processing options in my blog. I include the Google Cloud Run in this table, even though I didn't have any questions on this one in my exam, but since the Cloud Run was GA at the end of 2019, I think you will start to see it in the exam. Cloud Run offers a native serverless experience that lets you to go from the container to URL within seconds for increased developer velocity. The keyword is serverless container. There are 4 categories in compute and processing options: GCE in infrastructure as a service, GKE and Cloud Run for containers. GAE has standard and flexible options in platform as a service, and Cloud Functions in functions as a service. I collected the features comparison such as scaling, language support, background processes, request timeout, and the others to help you select the right service in your exam. For example, if you just want to focus on the application development, but you do need to install the third-party binaries, then you should use App Engine, a fully managed serverless platform, but with a flexible option to support custom runtimes. Also, if you want to learn more on which serverless compute platform you should choose among Cloud Functions, Cloud Run, and GAE, then take a look at the serverless options decision tree. It will help you to understand the specific requirements such as the A stateless HTTP versus event-driven, need Kubernetes versus configurable hardware, custom language, and system binary, or the unit deployment. Google Computer Engine offers several types of storage options for your instances. Disk options for block storage, cloud storage buckets for object storage, and a file store for the file storage. In here, I highlight the keywords of these storage options for the exam. Disk options have a persistent disk, local SSD, and RAM. Persistent disks are durable network storage devices that your instances can access like physical disks in the desktop or the server. The data on each persistent disk is distributed across several physical disks. When you configure a zone or regional persistent disk, you can choose either standard persistent disk, balanced persistent disk, or SSD persistent disk. Standard persistent disk is backed by a standard hard disk driver. The other two options are backed by solid-state drivers. Local SSD is physically attached to the server that hosts your VM instance. Local SSD has a higher throughput and lower latency than the standard persistent disks or SSD persistent disks. The data that you store on the local SSD persists only until the instance is stopped or deleted. Keywords for the exam are higher throughput, lower latency, data lost if the instance is terminated. With these disk options, you can mount a RAM disk within the instant memory to create a block storage volume with a higher throughput and a low latency. RAM disks work well when your application expects a file system structure and cannot simply store its data in the memory. RAM disks alone do not provide any storage redundancy or flexibility, so it is best to use RAM disks in combination with other instance storage options. Now let's take a look at the object storage. Cloud storage buckets are the most flexible, scalable, durable, and cost-effective storage option for your VM instances. If your apps don't require the low latency or high throughput, then you can store your data in a cloud storage bucket. The last one is a file store that provides high-performance file storage. You can mount a NAS file share on a VM instance. Now, let's move to the comparison of these storage options. Again, I highlight the keywords to choose the right option for the questions in the exam. Let's look at the capacity. Each persistent disk can be up to 64 terabytes in size, so there's no need to manage arrays of disks to create large logical volumes. Each local SSD is 375 GB in size, but you can attach a maximum of 24 local SSD partitions, so that gives you a total of 9 terabytes per instance. Cloud storage buckets give you almost infinite storage. On the scope of access, you can configure a zone or regional persistent disk. Regional persistent disks provide a durable storage and the replication of data between two zones in the same region. Local SSD provides local block storage directly attached to the VM. Cloud storage buckets can provide worldwide accessibility and worldwide storage locations. Performance. Local SSD provides the fastest performance among other disk options. Only persistent disk can be used as boot disks. For example, GCE instance automatically delete boot disks when their instances are deleted by default. So to keep the boot disks after instance deletion, then you should use no boot disk auto delete option to disable. So you can see the command for GCE disk options are gcloud, but for cloud storage bucket is gsutil. Only the local SSD has no data redundancy feature. Computer engine automatically encrypts your data before it travels outside of your instance to any storage options. You can control the encryption keys with your own encryption keys except for the local SSD option. Now you may have the question on which GCP storage options I should pick up for SAN or NAS storage. If you confused between SAN or NAS, don't worry. Here's the explain. SAN stands for Storage Area Network, which is a tightly coupled network of multiple devices that work with the block-based data. So the persistent disk is a good choice for SAN. NAS stands for Network Attached Storage. It's a single storage device that serves files over Ethernet. So you can choose either file store, Google Cloud Storage, or persistent disk for NAS. The cost-effective option should be Google Cloud Storage. If you need to mount file shares on clients in a remote network, then use a file store to achieve this. The last one is how to transfer the data to GCP. You can use online transfer to move data to Google Cloud Storage via the network. But for big data transfer, such as from on-premise to the GCP, then choose the transfer appliance. From cloud to cloud, such as between the Google Cloud storage buckets, from AWS S3 to GCS, or HTTPS locations to GCP, then choose the transfer service. Let's walk through the third one, Cloud Load Balancer's decision tree. What is a load balancer? A load balancer distributes the user traffic across multiple instances of your applications. Use a single IP address to serve as the front end and auto-scaling the back end to serve traffic. It is also integrated with Cloud CDN for cached content delivery. It allows you to set up the backend traffic subject to firewall rules. Google provides the following cloud load balancing options. Global load balancing for when your applications are available across the world. Regional load balancing for when your applications are available in a single region. External load balancing for when your users reach your applications from the internet. Internal load balancing for when your clients are inside of Google Cloud. Cloud load balancing supports HTTP, HTTPS, TCP, and UDP traffics. Let's take a look at this summarized GCP Cloud Load Balancer types table, including whether the load balancer uses an internal or an external IP address, whether the load balance is regional or global, and supported pass-through or proxy-based load balancing and traffic types. So you can set up global load balancing on HTTP, HTTPS, SSL proxy, and TCP proxy. TCP UDP traffic is always set up with the pass-through regional-based load balancing, no matter the traffic comes from external or internal. Based on the summary table, now let's move to the decision tree. The decision tree divides the load balancing into external and internal. Then, based on the traffic type your load balancers must handle and the questions related to, such as SSL offload, global load balancing, and preserved client IPs, to determine which load balance should choose for your application. So the decision tree will help you to choose exactly what you need from cloud load balancers. Let's walk through the first one, Cloud Network Connections Decision Tree. Google provides Cloud VPN, Cloud Interconnect, and Cloud Peering for cloud network connections. Cloud VPN and Cloud Interconnect are the Google Cloud products for cloud network connectivity between your on-premise network and Google Cloud, or from Google Cloud to another cloud provider. Cloud peering is the option for connecting Google G Suite and Google APIs. Let's take a look at these products. If you need a private-to-private connectivity, then Cloud VPN is the best choice. Cloud VPN securely connects your peer network to your VPC network through the IPsec VPN connection. Traffic traveling between the two networks is encrypted by one VPN gateway and then decrypted by the other VPN gateway. This protects your data as it travels over the internet. You can also connect two instances of Cloud VPN to each other. Each Cloud VPN tunnel can support up to 3 GB per second total for the ingress and egress. Cloud VPN supports IKE-v1 and IKE-v2 using the shared secret. Google Cloud offers two types of Cloud VPN gateways, HA VPN and Classic VPN. Here is the comparison table between HA VPN and the Classic VPN. Pay attention to SLA and routing options supported features. Both offer 99.99% SLA. HA VPN supports only dynamic routing with BGP, Broad Gateway Protocol, but Classic VPN can support either static and dynamic routing use BPG. You can configure HA VPN for more bandwidth. It is mentioned in the Google documentation with the example on how to configure HA VPN gateway with the 10 Gbps throughput. You can configure one cloud router, 4 HA VPN gateways with the 2 tunnels apiece for a total of 8 VPN tunnels in 8 total BGP sessions. Now let's move to the second cloud network connection option, Cloud Interconnect. If you need an enterprise-grade connection to Google Cloud that has a higher throughput, you can choose Dedicated Interconnect, which creates a dedicated connection, or Partner Interconnect, which uses a service provider to connect to VPC networks. Here is the comparison table between Dedicated Interconnect and Partner Interconnect. Pay attention to features. You can see the interconnect options are not through the public internet. Supported bandwidth. Dedicated interconnect have a maximum of 8 times 10 Gbps or 2 times 100 Gbps. Partner interconnect only has the supported bandwidth with the capacities of 50 Mbps to 50 Gbps for each interconnect attachment. The BGP configuration is set up between your on-premise routers and the cloud routers. The encryption is on application level encryption, which is different than what we see in the cloud VPN. The last cloud network connection option is cloud peering. If you need to access only G Suite or supported Google APIs, you have to connect through the cloud peering. Peering doesn't produce any customer routes in a VPC network. Traffic sent from a resource in a VPC network lives by way of a route whose next hop is either a default internet gateway, for example, a default route, or cloud VPN tunnel. There are two peering options, direct peering and carrier peering. Direct peering enables you to directly connect with the Google Cloud at a Google agent location. Carrier peering enables you to peer with the Google by connecting through a support provider, which in turn peers with the Google. Both products give you access only to G Suite and supported APIs and don't provide access to VPC networks and VMs in Google Cloud. With all the above overview on GCP Cloud Network Connections products, let's move to the decision tree. Now, it's time to use the decision tree to choose the network connection product to connect your applications to Google Cloud. You may want to ask simple questions such as, do you need to access a private compute resource on GCP? Do the bandwidth and performance of your current connection to the Google servers currently meet your business requirements? Do you encrypt sensitive information at the application level? Do you already have or are you willing to install and manage access and routing equipment in one of Google's point of presence POP locations? So understanding exactly what you need from the network connectivity is just as important as understanding what each of the cloud network connection products does best. There are three options for using relational database services in Google Cloud: using Cloud SQL, Cloud Spanner, or hosting the database on a VM using the GCE. If your relational database requires special operating system, custom database configuration, or special backup requirements, then you should host the database on a VM using GCE. Use cases fit Spanner based are sharded RDMS, scalable relational data, require manageability, or HA, multi-region support, or strong consistency. Otherwise, use Cloud SQL to support workloads less than 30 terabytes relational database. There are 4 options for using NoSQL database services in Google Cloud. Using Cloud Bigtable Cloud File Store, HBase on Dataproc, or hosting the NoSQL database on a VM using GCE. If your NoSQL database requires a special custom setup or lift and shift NoSQL database, such as MongoDB or Cassandra from on-prem to the cloud, then you should host the database on the VM using GCE. There is another situation if you require transactional consistency, the database might change, you need an adaptable database, or you need to scale to 0, you want no maintenance overhead scaling up to terabytes, then consider using the Cloud File Store. If you don't require transactional consistency, or you need HBase replacement in the cloud, you want a consistent sub-10 millisecond latency for handling millions of requests per second, you might want to consider Cloud Bigtable. If you just need to lift and shift HBase from your on-prem Hadoop to the cloud, then you can deploy HBase in Dataproc. By the way, the difference between Bigquery and Bigtable on handling analytical operations is Bigquery provides a sub-second query response time and a high concurrency. Bigtable provides a consistent sub-10 millisecond latency for handling millions of requests per second. Now let's do a comparison of Dataflow and Dataproc. Both are data process servers from Google Cloud. Cloud Dataproc is recommended for existing Hadoop Spark applications or machine learning and data science ecosystem or large batch jobs with printable VMs. Cloud Dataproc doesn't support the streaming process like Dataflow does. Dataproc does not natively connect to PubSub, but PubSub can use a single endpoint with the Dataflow to process the messages. And Dataproc requires a DevOps approach, but Dataflow is a fully managed service. Now let's take a look at the difference between Dataflow and Dataprep on data preparation, transformation, or cleansing. Dataflow does not provide anomaly detection, Dataprep does. Dataprep can be used to handle schema changes by data analysts without any programming knowledge, but through the GUI. Dataflow requires programming knowledge on Apache Beam SDK. Now let's compare the difference between Kafka and PubSub. Kafka and PubSub are very similar to each other. PubSub is Kafka's alternate solution in GCP with no ops and serverless. I provide the comparison between Kafka and PubSub here for your reference. If you are unfamiliar with Kafka, then you should at least learn Apache Kafka's architecture and concepts from Apache Kafka's website. The first difference is message delivery. Kafka promises to deliver messages exactly once. PubSub guarantees at least once delivery, but PubSub can work with Dataflow for exactly once delivery. The second difference is the message retention period. Kafka can consume messages published longer than 7 days ago. PubSub's message retention ranges from 10 minutes to 7 days. but you can store the post-historical messages in a database such as Cloud Bigtable or Cloud Bigquery data warehouse. The third difference is on log compaction or random access. Kafka's log compaction ensures that Kafka will always retain at least the last known value for each message key within the log of data for a single topic partition. There's no equivalent feature in PubSub, and also the compaction requires explicit reprocessing of messages or incremental aggregation of state. However, PubSub does provide replay and purge messages. You can consider using seek functionality to random message access. The seeking to a timestamp will discard the acknowledged messages manually after a retention period. The last one is on message ordering. Kafka provides keyed message ordering to promise the message ordering within a single partition of a topic. PubSub has an ordering key to guarantee the messages successfully published by a single publisher for the same ordering key in the same region. Thanks for watching, and as always, subscribe to my channel for more great cloud computing learning tips. See you next time.